Hi there, this is Daniel and you are going to get coded. In this video, we are going to continue our journey through the dictionaries concept in C#. As you saw in the first videos, I went through how to declare and initialize a dictionary and also how to use certain methods such as add, remove, and try get value. In this video, I'm going to continue on with actually using some methods and properties of the dictionary class in C#. And I'm going to actually sort a dictionary. And I'm not going to sort it per se, so I'm not going to sort the dictionary itself, which I'm going to do in another video. Right now, what I'm trying to do is actually sort a dictionary based on their value, or based on its values, and based on its keys as well. So I'm trying to make something else so that I can show you certain methods inside the dictionary class. If I have time right now in this video, I might also include how to actually sort a dictionary itself, but that's not the aim of this. So the aim is actually going through the rest of the methods of the dictionary class, okay? So let's try to go there, but again, before jumping over, just a reminder, a dictionary, whenever we think about dictionary, we need to remind ourselves that we are talking about key-value pairs. So whenever you have a collection, and you might want to have a specific key for a value, you might want to use the dictionary class. This is different from the array, because the array has integer indexes. So indexes starting from 0 and it's up to the end of the array -1, so the length -1. We are talking only about integers. But with the dictionaries, you can have keys as strings or objects or anything you'd like. So let me try to click on this and go into sorting. So as I said, I'm going to go over sorting. So how to sort an already given dictionary. As you can see on the left side right now, I have a store dictionary, which is initialized with some values. So I have peach, grape, lemon, coconut, 4 items inside this dictionary. And just a reminder, we are talking about a store. We are trying to emulate, we are trying to model a real life, a real world concept of a store, of an inventory. And this inventory has fruit types, and for each fruit type, we have a specific quantity. And this quantity is in kilograms. I chose double because we might have 15.5 kilograms, but for the brevity and simplicity of this example, I just chose to keep them as integers with no comma separated values. But because in real life we might have fractions of a kilogram, we need to use double. So let me try to create a console application to actually start writing this code. So file, new project, and I'm Visual Studio 2017. I have not upgraded to 2019. I might do that soon. I'm going to choose .NET Core and console app, and then let's try to say dictionary, sorting. Let's try sorting dictionaries. Sorting dictionaries. That's the name of our project. And then we are going to click OK. This already exists. Yes, I'm sorry this already exists because I already recorded myself for this specific video, but I didn't like how the video ended up being. So yeah, sorting dictionaries, sorting dictionary. I'll just put that for my lack of imagination right now. So let me try to wait and we are done. I'm going to zoom in a little bit. Let me know if this is all right, because in some videos it looked like it's too small. I think this is like perfect. Okay, so we need to create a new store dictionary. So I'm going to scroll down a little bit. I'm going to remove this line and I'm going to start typing. So var store equals new dictionary. So I want to create a new instance of the dictionary class. And right now you can see that there is no such thing. There is no such thing as dictionary. And we have a red squiggly line underneath our dictionary saying that the type or namespace for this could not be found. In order to solve this, we need to click on this and we need to press on Control Dot. This is going to open up our Intellisense, and this offers us 3 different options or suggestions that we can use. I'm going to choose the first one, which is going to add a namespace for this dictionary class. If I'm going to click on this and I'm going to scroll up, you are going to see that a new using statement was added at the top of the file. And this system.collections.generic, this specific namespace contains the definition of this dictionary class. Let me try to scroll down and let me try to continue on typing. So the dictionary class is going to have a T key and a T value. So the type of the key and the type of the value. As I already said, the key has to be string because this is the fruit type. So peach or grape or lemon. I'm going to say string, and then I'm going to say double for the value. So the quantity for each specific fruit type. And then I'm going to open up the curly braces. You don't need parentheses when you have object initializer. And also you don't need a semicolon because we don't want to end the statement. Whenever you use object initializer, meaning the curly braces, you can omit, you can leave out the parentheses, but you need to use the semicolon, or rather add the semicolon at the end of the braces. Inside, we are going to use the indexes to actually specify the items that we want, the initial items in our dictionary. So I'm going to have the peach fruit type, which is going to have 15 kilograms, grape, and please put them in double quotes, in quotation marks, because we are dealing with strings, as I said here. So grape is going to be 23, another one, lemon, 8, and the last one is going to be coconut. So coconut is going to be 10. So these are the fruits that I have in my store. Again, I'm going to just cover a little bit the var keyword. In C# you are able to specify, or rather initialize or declare a variable with using the var keyword. If I'm going to select it and then Control Dot, press on Control Dot, you can choose to explicitly use the type instead of var. If you click on that, it's going to replace var with the actual type. But since we have on the same line the type, it is a little bit redundant to actually also have the var being replaced by the type. So in this specific case, it makes more sense to actually use var instead of the type itself. So once we have our dictionary, let's try to scroll down and see what we want to do. So we want to sort it by keys. So we have several keys, and you see that the dictionary right now has no specific order. So it's not sorted alphabetically or by the number of the value, by the quantity. It's not sorted in any way. It is just random. So we can choose to sort the dictionary by the keys, so by the keys that are inside it. One way to do that is the approach that I have on the left. This is just one approach of the many approaches that are when you want to sort a dictionary. The approach that I chose is to use the array. So you can actually use the keys array. So let me try to start typing that, and I'm going to explain a little bit more concepts in this because this is very interesting. So sorted store by key. Again, a very specific name, a very descriptive name actually, and this is what I want you to learn when you want to declare a variable. Try to not be shy about writing long names. This is not a long name, this is a descriptive name, and this tells other developers and even yourself what this variable is going to hold, what this variable is going to refer to as its value. So equals store. So I'm going to call the store, and then I'm going to press enter and say dot. This is going to show a list of all the methods with the cube. So whenever you see the cube, the purple cube on the left side, this means that this is a method. And whenever you see the key sign, this is a property. So a method is a function, but because we are in object-oriented programming, we call functions methods. So this is just a way of actually a way of talking about it. So the language that you want to use whenever you write something in an object-oriented programming. But again, it's just a function. There's no difference between a function and a method, just the naming, just because the paradigm that we use. And then the property, which are variables inside classes, basically. But as of now, we are interested in the keys. So the dictionary class itself provides certain properties and methods. One of the properties is called keys. And these keys property, if I'm going to hover over, it says that gets a collection containing the keys in a dictionary. And the returned collection is key collection. So the return type is going to be this key collection. This is new. We have not seen this before, actually. And this is again built in C#, built in .NET. And this is again the keys out of this dictionary. Let's try to press enter, and I want to transform this to array. So if I'm saying dot and then to array, it's not here. I don't have this method here. Why I don't have this method here? Because maybe you might say we don't have a using statement, and that's true. Let's try to go into this and then control dot, press control dot. You can see that we have a suggestion using system.link, and this is very important. I'm going to click on this. This is going to add system.link over here, and right now you can see that we have no error right now on our toArray method call. So we are able to call the toArray method. But what I want to focus right now is on the system.link namespace. This is a very important namespace in C# and .NET. Previously or prior to including this, we didn't have the toArray method. If I'm going to comment this by pressing on Control K, or C, Control C. If I'm going to comment this, you can see that again, this is an error. We cannot see it. If I'm going to say dot, we have only these methods. We have some methods and one property, count, for the key collection, and then they get an enumerator and some other methods. But what I want to focus is on this get enumerator and what this link is actually. Whenever you are trying to have a collection inside C#, you might want to have specific methods to operate on that collection. You might want to get the first item that complies with a certain rule, or you want to sort them, or you want to find something in them. C# already comes with some predefined methods that can help you whenever you deal with collections. And in order to do that, your specific collection has to implement an interface. So let's try to go to the dictionary class. This is the dictionary class that we want to use from C#. If we go to the definition of that class, so right click, and then you have here, go to definition. You can also press on F12, but because I'm recording my screen, if I'm pressing on any of those F10, F11, or F12, I'm going to stop recording, and that happened previously, and I lost the video. And I continued on, and I was talking to myself because the video recorder just stopped. So if we press on go to definition or F12 on your machine, we go to the actual assembly, and assembly is a project. So whenever you deal with assemblies, it's just a project. And we have a namespace, system.collections.generic. And inside this namespace, you can see that I have a dictionary class. I wanted to collapse this, but I couldn't. So this dictionary class has some methods, some constructors, some properties, and also it has some classes inside the key collection that we just saw. So what you are seeing right now is actually inside the .NET framework. This is inside the actual .NET framework, and this is the code that comes with the dictionary class. What I want you to focus is public class dictionary, and if we go a little bit on the right, you can see some interfaces, and I've not covered interfaces so far, but I'm going to cover them soon. But if we continue on, again, I know this might be a little bit difficult for you to understand, but I'm here to just show you a little bit of what it is underneath the dictionary class to explain some concepts. But we are going over these things over and over and over again until you are going to understand them. So this is just the first time when I'm exposing you with so much code. But we are going to cover them more in the future, because this is the approach that I want you to learn as a developer. I want you to be aware of what lies underneath using a class and how to actually go there. So, having said that, let's try to continue on. And I want to show you these two interfaces, IEnumerable and IEnumerable. The first IEnumerable is for generic types, so is of type T, and we have the T specified, and then we have an IEnumerable for non-generics, as you can see here. So there is such thing as generics and such things as non-generic collections. What are those? So far we know what a collection is. So a collection is a group of values. So instead of declaring a variable for each value, we can have a collection that we declare once, that we can store in a variable, one collection variable that holds several values. In our case, we can declare a store that contains several fruits with quantities. A collection can also be an array. You have an array that contains several numbers inside that specific array. What I want you to understand is that in C# collections must implement IEnumerable, and this IEnumerable interface is very important because this is going to allow that specific collection to have access to call methods from the link namespace. And it is pronounced link, so not link queue. Don't pronounce it link queue, that's not correct. If you go to the official documentation on Microsoft, you are going to see that link is pronounced like that. So the namespace that we just saw in our, let me try to click on this, keep open, on our program here, so system.link. If I'm going on the IEnumerable itself, so right click on it and go to definition, you can see that this interface has just one method. If I'm going to open these collapsible braces, you are going to see the IEnumerable interface and the get enumerator. So whenever a collection implements this, it implements the get enumerator method. And what is an interface, you might ask? Well, an interface is similar to a class, but you cannot initialize it, you cannot create an instance of it because it doesn't exist. It's just there to specify, oh, if you want to implement me, you have to have an implementation of this specific method. Again, this might seem complicated, but it doesn't have to be so. Why? Because interfaces are just there to have, or rather keep your code clear and organized in a way. Because the IEnumerable, once you implement that, that becomes a collection. Because collections, whenever you think about them in C#, they are IEnumerable. Because they implement this, get enumerator. What I omitted to actually explain was the difference between non-generic and generic collections. Back in the day, we were having only non-generic collections. So we were having collections or arrays, let's say, for example, arrays that contained anything. So you would be able to actually have an array that contained a number, a string, an object, just anything. It's like a full-blown mess of stuff. That is not useful that much, because when you are going to use that specific collection and iterate and operate on it, you are going to experience problems. You are going to experience problems because for each item you have to perform operations differently. And for example, if you want to add numbers together and all of a sudden you have a string, then C# is going to think, oh, you don't want to add numbers, you want to actually concatenate them. So it's going to concatenate a string, and then the next time it's going to add a number, it's going to be a mess. But also, not only that, but with non-generics, you are going to have the problem of boxing and unboxing. That's another concept in C#, which boils down to just having types for the values and knowing what the type is and what methods to use on those specific types. And you can box them and unbox them for specific types. That's not what I'm going about on this video. What I want to show is the generic type of that. So I think starting with C#4, so a couple of years ago, C# added the idea of generics. So you can have a collection and you can specify what type I want this collection to be. If it is an array, I want this array to only contain strings. If it is a list, I want this list to only contain objects of car class. If I'm going to have a store for cars, or a book class, or just a list of strings. Once I declare that, I am unable to add a number or an object to a list of strings because it will not allow me to do so. Just as in our example, our store is a generic collection because it is a dictionary that has a string as the key and a double as the value. So we have specific types for the dictionary itself. So this makes it a generic collection. And when we are going to add, so store.add, for example, you can see that it requires us to pass a string and a double. If we are going to pass numbers, only like 2 numbers, for example, we are going to have a red squiggly line underneath. And it says that the argument 1, the first argument, cannot convert from int to string. So it, C# or .NET, expects a string for the first argument, but we provided an integer. This is what a generic collection is. If it was a non-generic, we would not have this problem and we could have added that. And maybe that's the thing that we want. Maybe in a company, for a specific use case, they might want a collection with many different types. But many times, I think 9 out of 10 times that you are going to write your C# code, you are going to rely on the generic types, because these generic types will first of all point out any errors that you are writing in your code. Not after you execute and build it, but when you actually run it, when you actually write it. So even before compilation. Compilation means whenever you are like rebuilding the solution, you are like compiling, and then running whenever you like press run and actually run the code. When you write the code right here, this is like before both of these operations, and this is the beauty of C# because it offers you in time type inference and type checking for your code. So this is what non-generic and generic. But again, we went from having from the discussion of enumerable. So now we know that we have collections. They can be generic and non-generic. Non-generic, they are old, like vintage. They used to be, back in the day. You can still use them, but you don't want them. You need to use generic types. And then the enumerable is useful because it offers the or makes collections work with link in a way. So if I'm going to press on that again, you can see that we have only these methods that come from the keys class, which is actually the key collection class. If I'm going to include system.link and then put the dot again, you can see that I have a whole other range of methods that, of a whole other range of methods available. And all these methods, take while, take class, to dictionary, to list, to lookup, like all these incredible methods for ordering. Let me try to show you that again. Ordering, order by descending. They all come from link, and they are available because this key collection, this dictionary and this key collection, both actually implement the IEnumerable. If we go back to our dictionary class inside the .NET framework, you can see that the dictionary class here has a definition for the key collection, which also implements the IEnumerable. You can see both the generic and the non-generic version of IEnumerable being implemented. And the implementation, where is it? Is here. The get enumerator. This actually is implemented. You cannot see the implementation because you cannot see actually the code here that Microsoft, or rather the developers at Microsoft coded inside, but this is actually implemented. You know, it's implemented in C#. So if I go back to the program.cs, I have again a wide range of these methods. Which method is the toArray that we needed, that we added previously? So this is why we are able to actually have this method available. We added system.link, and this system.link provides extension methods. These are extension methods. Let me try to write it again. Whenever you are seeing this down arrow next to the cube for methods, it means that it is an extension method. And we implemented an extension method, I think, in the second part of the Dictionaries series. And basically, whenever you have a dictionary, whenever you have an extension method, it means that you don't necessarily want to alter or modify or change the structure of a class, but you'd rather just want to add extra behavior to a class. If you want that, you have to create a separate static class, and inside that one you pass in, or rather write, a method that is going to be an extension method. We did that in the second part of the dictionary series, so go check that out if you'd like. And also I'm going to create more extension methods because they are very useful. They are very useful, and you are going to see them more in future videos. So again, that was the idea about the toArray. Why we have it here? So we have it here because this is an IEnumerable collection that implements IEnumerable interface, and by using the system.link namespace, we are provided with a set of extra extension methods that we can use on these collections. What I would like right now is that I would like to actually replace the var keyword with the actual underlying type of this variable. So I'm going to click on var and then control dot, use explicit type instead of var. So you can see this is an array of strings. This is denoted, the idea of being an array is denoted by the usage of the square brackets that you can see here. So far, what have we done? We have declared and initialized a dictionary, and then we called the keys, or rather we accessed, so we didn't call because this is not a method. We accessed the keys property of this store dictionary, and then we called the toArray method of this collection. So right now we have the keys, and once we have the keys, we can sort them. So we can actually sort the keys in the array. So we can just type array, and this is already there. This is from system.array. This is available because we have the using statement, and you can see that one turned blue, so it's not faded anymore. Array.sort. This is going to sort the dictionary. And in order to use this method, we need to pass in the dictionary that we want to sort. And the dictionary is the one that we just created before. So sorted dictionary, sorted store by key. I would like to just explain 1 second, 1 moment, this specific method. If I'm hovering over this method, this sort method, you can see that it returns void. It doesn't return a value. This is what it means. It returns nothing. And if we read the description of this, you can see that it stores the elements in an entire array using the iComparable interface, blah, blah, blah. So it continues on. What I would like to explain now is that this sort method sorts, or to say it in another way, reorders the items inside the specific array in place. These 2 words, in place, it's an expression that you are going to hear in programming very often. And what it means is that it doesn't return a new array. So you are not going to say sorted array result equals. This is not possible because this returns void. It returns nothing. What this method does, actually takes in an array. Let me try to remove this. Takes in an array and stores the item inside it. So it doesn't create a new array. It just reorders the items that are inside that one, reusing the same array. And this is very important because from a performance standpoint, this is efficient. You are not creating another array. And right now we don't have a problem because we have just 4 items, but imagine having 4 million items. That's a lot of items. And if you are going to create a new array for those, you are going to have 8 million items. So 2 arrays all of a sudden. So right now this makes total sense because it's more performant. And this was one of the reasons why I didn't want to sort the dictionary itself, because there is no such way of actually sorting a dictionary. A dictionary doesn't have an ordered way in itself. It is just a bunch of indexes. It is actually a hash table in a way with indexes, which doesn't know any ordering in itself, any sorting. There is a class in C# actually called sorted dictionary. Sorted dictionary, and you can see it here, but I'm not going to talk about it right now. But there is such class. But basically what this class is, or implements more than the dictionary, is that whenever you add a new item, it's going to be sorted automatically. So it's going to keep a sorted index list inside the dictionary. So it has the notion of sorted keys. But for now, we want the dictionary class so that we can show how to actually sort these. So as I said, we use the array.sort to actually sort it in place, so we don't need to create a new one. And that's the beauty of this approach that I chose on the left. This approach that I chose to actually explain in this video. So we display the store dictionary based on this array. So let's try to use the for each. Again, whenever you have a collection, an enumerable, right now we know what that is, you can use the for each and then tab. So press write for each and then tab. This is going to show it. And then you continue on by pressing tab. We are going to leave item as it is and then tab again. Instead of collection, we want to specify the collection that we want, so store. I'm going to press enter, and then enter again is going to jump inside the curly braces. So tab, tab, tab through those and then enter to go inside once you finished. What I want to do inside the for each is I want to print out one item, one by one. So let's try to write this down and then we explain it. So CW, and I'm going to say $, and then quotation marks, and then curly braces. Oh my God. Key, and then again curly braces, store, and then parentheses, key, and then the curly braces. I have a mismatch between these two pieces of code. You can see that here I called it key, here I have store. So we are not going to iterate over the store, and this is my mistake because I didn't check the code. But again, this is a good thing because I want to reiterate this, re-say this. The store is not sorted. We just extracted the keys out of the store in a new variable, in a new array variable, and we sorted that array variable, and this store is unchanged. This store contains the values being unordered, so it has the initial value unchanged. So we don't want to iterate over the store, we want to iterate over the sorted store by key, and then instead of item we want to have the key. Also, I would like to actually rename this. So this is not sorted store by key, this is actually sorted keys. So let me try to right click on it and then rename, and sorted keys. It is a better way because I want to again express the idea this is not related to the store anymore. Yeah, this is like sorted keys from store, or sorted store keys. Yeah, sorted store keys. Yeah, naming again might be very difficult, but please take your time. The most or the best code that you're going to come across is the code that is actually well thought through, with good names for the variables and well structured. So this is what I try to have in my videos as well. So you can see I am iterating over the sorted store by keys, and I'm printing out to the console each key from this array, but also I am going inside the store and accessing the item by the key, and this accessing is going to return the value for this specific key. Let me try to just run it, and I'm going to explain it even more. Instead of console write line, I want read key, so that our console is going to be open or remain open. And let's try to run this. Oops, I nearly dropped my microphone. Okay, so you can see right now that I have coconut, grape, lemon, and peach. So the order is changed because previously you have peach, grape, lemon, coconut, so they were in random order. Right now they are in alphabetical order because we ordered them, we sorted them in on this line. How this worked? Well, it worked because we extracted the keys and we converted those to an array so that we would be able to call the sort from the array to sort them in place. So for a performance standpoint, to be more efficient. Because we have them stored, or rather sorted in the array, we have the for each. In the for each, we don't need to have the store, the dictionary itself being sorted, but we can only iterate through the keys, and one by one we access the value. We want to get the value out of the dictionary as we want. So we go them one by one as we want, which is very interesting. So let me try to show you that. Right now we are going to debug. So let's try to set a breakpoint. I know you might not have heard of these terms, debug, breakpoints. Oh my God, what is it going to do? So in order to check if your code works, you are able to debug it. So you can choose a line that you want to go into, and you can click next to that line on this gray space here, and you can put a breakpoint. This red dot here represents a breakpoint. When I'm going to click on this start, the program execution is going to stop at the first breakpoint that it encounters, and the breakpoint that it encounters is on the line 19 that I just set. Whenever you set a breakpoint, again the execution of the code stops, and you can use two important windows. You can use the autos and the locals. Right now I don't have the locals, I don't know why. So you can go to view and you can try to search for the locals window if you don't have that one. I really don't know where is that. Yeah, I lost my locals window. Yes, I'm so sorry for that. I lost my local windows. I don't know where to find that again. It should have been here. Anyways, we are going to use the autos until I'm going to find out how to put the locals again. We can also pin it here. So you can see right now I have 3 variables. And I have here the name of those that you can see in the code and the value for each one that they hold or they refer to. Right now the sorted store by key is null because this specific line, this specific statement over here, this is a statement even though it's spread on 3 lines. This is a statement because it has 1 semicolon here, so it's a statement. Is null. So this variable here points to a null value because it has not been run. It has not been executed yet. Then we have 2 variables. We have the store variable, which is our dictionary, and then we have our store.keys. This is again just a property. This is what we have from the autos. If we had only the locals, we have just like these 2 variables. This is why I wanted the locals window, because the auto sometimes displays way too many variables that I'm not interested or properties that I'm not interested. But again, the keys, these are the keys, these are the store values, the items inside the store. You can see them that they are not ordered, so they are in the exact same order as I initialized them here. Let's just continue on. I want to execute this. I want to extract them and put them in an array. So I'm going to press on this step over, so the arrow that goes over. And right now you can see that it returned a system collection something. It returned an array here. And right now the sorted store that previously was null right now has 4 values, has the peach, grape, lemon, coconut. And right now they are not ordered, so they are in the exact same order as they are in the store. So this is the store, this is the array. They are in the exact same order that they are in the dictionary store in the index array. So they are the exact same order because we have not executed this array.sort. So we are here and we are trying to execute this line. If I'm going to step over, so if I'm going to press on this, you are going to see that these values are going to be sorted. So if I press on step over, you can see that they turned red, some of them, because they changed. And the sorted store by keys has just been sorted. It has been ordered based on the key, so alphabetically by the key value. So right now, this sorted store keys has the keys sorted. Let's move on. We have the for each. Right now I want to step into. So if I step into, it goes through the keys one by one. So right now the key you can see is null, but if I go inside, the first key is coconut. So the first ordered key from the array is coconut. It's going to print out the key. This is what we want to do. So inside the for each, I have just one statement, console.writeLine. This is going to print out to the screen this string. And this string is a string interpolation denoted by the $sign. And we chose to have the string interpolation here because I want a dynamic string. I want a string that has some format inside. I want to present it like nicely to the user, to the console. But I also want to insert some dynamic values one by one. So you can see I tried to insert a key and I want to insert the value from that. The key I already have is coconut. And what it tries here to do is it's going to go into the original dictionary and it's going to find the key. What is the key? The coconut. Try to get the value. Try and find for me the value. It's going to go and try to find the key, coconut, and then it's going to get 10. Let's try to see if it does that. If this is going to return 10. If I'm going to step into, you can see that string.format returned. This is like the string interpolation. It returned coconut : 10. exactly the value that I have, the value that I have in my dictionary. So it knew how to access the original dictionary by the sorted key and to get the value. So we don't need to have an extra dictionary being ordered. We can just use our original one by just accessing the items in an ordered way, in a different way. Not just one by one as they are, but in a different way as they are specified in the array, not in the dictionary. So this is like a smarter way of doing it in a way. But again, if this fits your use cases, sometimes you might want, or you have to like create a new dictionary. And then we go again. We go into the in statement, and then we try to go to the next key. The next key is grape. And whenever you debug your code, you can see that sometimes it turns red. It means that the value changed. So whenever you see the red highlight or the red font, you know that, oh, the value changed for this specific variable on that statement. And if we go again, this grape should return us 23. So it should go into the store and should try to find the grape item. The grape item, or the quantity associated with the grape item, is 23. Let's see if this knows how to do it. And it knew 23 because that is associated with the grape inside the dictionary. So we can access, again, values inside the dictionary by the key. And then we can continue on as many keys that we have. So lemon is going to go inside, and you can see one by one they are printed out. And then lemon, one by one. This is peach, the last one. The last time is going to try to iterate again, and you can see it had no items more. Again, this for each works for collections because this implements IEnumerable. And how this works, this calls the getEnumerator method from the IEnumerable interface. So if you go back, this IEnumerable over here, if we go to the definition, this contains the getEnumerator. For each calls this getEnumerator, and this is how it works. It works by calling items one by one. Give me the next, give me the next, give me the next, until this doesn't return anything. And if this returns null, it means that no item is there anymore. And it exits the for each. And this is how for each works with collections. It tries to iterate over each item one by one, and when the collection is finished, the getEnumerator doesn't return an enumerator anymore. It returns a null for that one, and it exits. And you can see if we just continue on, we have our array being displayed on the screen. I think this is for now. The next part of the sorting, I'm going to cover the sorting by values. So how you are going to go about sorting an array by values. So instead of sorting them by keys, you might want to sort them by this. So the numbers that we have as the quantity. So to be 8, 10, 15, and 23 in that order. But that I'm going to explain in the second part of this video. And also I'm going to show you how to actually sort a dictionary itself. So this is not, again, sorting a dictionary. It just creates an array that has the keys from that specific dictionary ordered, and it then tries to access them one by one as they are ordered. But this code keeps this store untouched, unchanged, so the values are kept intact, they are not changed. And this is efficient because you only extract the keys. And normally, and hear me out right now, normally with dictionaries, the problem with performance doesn't come from the keys, it comes from the values. Right now you cannot see that because this is just like a number, it's just a double. But imagine having a big object. So this is like, I don't know, a car object or a report that you might want to have for your for the company that you work with, and the company has like reports, and that report has like details and dates and customers and products. imagine how many values you'd have inside that report and how big this dictionary is going to become because of those values. So normally that's not the problem, you know, like normally just extracting the keys and sorting them might not be the problem, because the keys are just like that, just like strings, you know, strings or numbers sometimes, or GUIDs for uniquely identifying an item. So they are just like working like that. So normally this is a good piece of code, you know, to have like a more performant code. But again, you might have a specific use case when you want to actually return a sorted dictionary. So that was it for now. I'm going to keep the code as it is, because I'm going to continue on with the second part of this. So you're going to see the code as that. And also, I link the code in the description down below, so you can actually see the code. So I create a gist, I think it's called, on GitHub, and you can actually see the code there and copy the code there, because I know how frustrating and just frustrating can be to see a tutorial and not have access to the code. So I'm giving you access to the tutorial itself and also to the code that you actually see in this video. So again, thank you so much for watching. I hope you enjoyed this video about dictionaries, about sorting them by keys, and I hope that I'm going to see you in a future video. Goodbye.